Theorem 11, 12 and 13 you will eventually prove. I just want to go through them now, and you are going to get used to using them first. Eventually we'll prove them. So Theorem 11, it talks about three parallel lines and transversals. Well, we have before talked about two parallel lines and a transversal. Now you should be using rulers and all to do this. We talked about alternate angles, the ones tucked into the corner, or the backwards Z. We talked about vertically opposite angles. Now you don't have to have parallel lines to have that, but just saying that they exist there as well. And you have those two corresponding angles. And now we're going to go on to three parallel lines. And we're just going to have a look and see what happens if we draw a transversal through these. So let's just draw a transversal here. And what this says is, if three parallel lines cut off equal segments on a transversal, then they will cut off equal segments on any other transversal. So, do you see the way these aren't the same distance apart? So I'm going to go and just redraw my three lines, just to maybe look a little bit like closer to that. So I have my three parallel lines. I draw a transversal, and maybe I measure these and they're 2 centimeters. If that happens, now I know that if I draw any other transversal, so let's do one, maybe any other transversal at all. These will also be cut off into equal segments. So see that this is a 2 and a 2. Those two are the same. Maybe I get out my ruler and I measure this and I find out it's a 3. Well, then I automatically know this will be a 3 as well. Just like here, maybe I had my 3 parallel lines and I drew my transversal and I noticed that this was a 3 and this was a 3. Well, then any other transversal, if I draw another one and I find out that this is 4, well, I automatically know this is a 4. And if this was like a 2.8, well, then I automatically know this is a 2.8. So once it happens for one transversal, every other transversal will be the same. Theorem 12. If you have a triangle and you have a line parallel to the base of the triangle, and it cuts one of the sides in the ratio of m:n, so here it's 3:2 when you simplify that down, or 9:6, then it also cuts AC in the same ratio. Which means that, you know, AX over XB is going to be the same ratio as AY over YC. And that's actually quite a flexible rule, because you could say AB over AX is the same as AC over AY. Or you could say AX over AB is the same as AY over AC. And we'll be using, that rule to do questions in the next exercise. And as I said, that rule is pretty flexible. Here AX over XB is the same as AY over YC, or XB over AB is the same as AC over AY, and so on. There's loads of ways that you can do it. It's just a very flexible rule, and that only occurs when we have a triangle and you have a line parallel to the base that cuts through your triangle. It means your sides are going to be cut in ratio. You can have a look at some of these examples if you want to be absolutely sure, but I think it's okay, and you would have seen some of that at junior cert. You would have had a look also at similar triangles. Similar means that, okay, they're not the exact same size, they aren't exactly the same, they're not congruent, but it means that their angles are the same size. So all three angles will be the same size. And if two triangles are similar, then their sides are proportional. So to be honest, if you look here, there's a big triangle, there's a small triangle. Here we have two corresponding angles. Here we have two corresponding angles because of my parallel lines. And then the third angle has to be the same because it's the same angle in the three. So this rule is already talking about similar triangles, even though it doesn't explicitly say it. So if you have a triangle and you have a line parallel to the base, then your sides are in ratio. But if we look a little bit deeper, if we just look at the small triangle and the big triangle, they are similar. So similar triangles also have sides that are in ratio. And that's what 13 is about. So, just to remind you as well, this isn't anything to do with what's in the book here. Just want to talk about congruent triangles. You would have looked at this at junior cert. Congruent triangles means triangles that are exactly the same size, shape, they have the same angles, they have the same area, everything about them is the same. But I don't want to have to measure everything about them to know that they're exactly the same. So I can check the side length of them and see does it match with another side of a second triangle. So if I wanted to see, are these two triangles exactly the same? I could measure the length of that side and see is it the same as that one, because remember we're looking at the sides have to match, so I probably have to like flip that first one up so that we could see which sides are matching. And again, you just check all three sides. So you could check side, 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 and if you can tick off that all three sides are the same, so you know this one is the same as this one, and this one is the same as this one, and this one is the same as this one, or whatever way it works, then you know they're congruent. So that's handy. And instead of calculating everything about the two triangles, you only have to calculate three things. Or maybe you know a side, an angle and a side. If you can tick off those three that match, then you know they're congruent. Angle, side, angle. If you can tick off those three, then you know your two triangles are congruent. Or right angle. So if both triangles have a right angle in them, if the hypotenuse are the same length, and if any other side is the same length, then we don't have to go through the whole process of checking everything about the two triangles. We can actually just say, right, we know they're congruent. So I just wanted to recap on that because I'm not sure how long ago it is since you've seen that. If you're happy with all that information, have a go at exercise 6.4. You don't have to do every question. There's not a lot of questions there. You'll know, I think, how many of the questions you want to attempt. Maybe try every second one to start off with, and do more if you feel like you need that. And yeah, and I'll gladly put up any of these on YouTube so that you can see how you're getting on with them. It's just that you haven't probably tried questions to do with geometry in a while, and it's just going to take a while to refresh your memory, and maybe just get used to using the new one that I feel you certainly wouldn't have seen at junior cert, which is the three parallel lines and the transversals.